devices as AAG or ACG. So we need a scalable, cost, and non-intensive method that use easily collected data from sleep behavior. To address this issue, here our research objective. Our main objective is to detect risk as level low, moderate, and high using sleep behavior features. A hybrid machine framework combining supervised learning for classification and unsupervised learning for clustering. Additionally, PCA is applied to improve interpretability and visualization. Now let's take a look at dataset used in this study. We use Kaggle sleep dataset containing 130 samples and 16 sleep-related features. These features including sleep duration and sleep, deep sleep, light sleep, time in bed, and restlessness. Missing value were handled as smooth was apply the balance to target classes. Know that we understand the data, let's go you through the first, we perform preprocessing and bring missing value, normalization, and smooth class balance. We run several classifiers including SVM, KNN, random forest, and XH. We apply PCA to reduce dimensionality into 2 or 3 principal components. Finally, k-means with k=3 was used to explore to natural group structure and generate possible levels. F1 macro score of 0.72, X9 of standard deviation 0.0587. XG boost achieved and the best performance with an F1 macro score of 0.9776, which is approximately 19%. Assemble method like XGBoost and random forest clearly outperform SPM. Next, let's take a look at the clustering result. K-means with K=3 a producial hot score of 0.3174 indicated moderate cluster separation. Kalinski-Harabas index of 16.91 and Davis-Baldwin index of 1.078. Interestingly, the cluster matched the actual stress level with 100% purity, and cluster assignment were then used as pseudo label to reinforce the classifier. This result led us to several key findings. First, sleep feature correlates strongly with stress level. Second, a hybrid model combining classification and clustering improve interpretability and robustness. And third, our results show that sleep and stress detection is feasible, practical, and completely non-invasive. However, this study has several limitations. The main limitation is the small dataset of 130 samples, which is affect generation. Sleep-only features do not fully capture external factors influencing stress, and cluster separation moderate, and SPM shows sign of overfitting. Finally, let me conclude this study and discuss with you. In conclusion, sleep behavior can serve as a reliable indicator for stress detection. Our hybrid framework improve performance and interpretability, and XGBoost achieve the best, strongest, and the best wrong perspective and result. For future growth, we plan to expand the dataset, incorporate multimodal such as HRV and mood report, and experiment with several models such as LSTM. That concludes my presentation. Thank you for your attention. I'm happy to answer any questions.
All right, thank you, Ms. Tania, for your presentations. Any other questions for the attendees, please?
Me.
All right, Mr. Hendra, please.
Yeah, thank
You
you.
still, Miss Tania still have
Okay, thank you,
2 more
Miss.
minutes, so I think one question is good.
Okay, one
Okay.
question. Does the dataset have class, Miss Tanya? The dataset have class? Can you provide a URL link to dataset?
Wait. Can you repeat the question?
Can you provide a link to the dataset? Your dataset from
The
Kaggle,
dataset from
right?
Kaggle. Can you
From
provide
Kaggle, right?
the link to the
Link
dataset?
URL dataset from Kaggle.
Yes,
Yeah.
from Tagore.
Why
Please.
you use classification and clustering you hybrid? Why?
Sorry, can you repeat the question? It's
Why
too
you
much here.
hybrid the method classification and clustering? Does the dataset have class?
Mhm.
Does the dataset have class?
Your datasets, Miss Tania,
Your
your
dataset.
dataset
Yeah, your dataset
have class.
have class.
Yes. Have class.
Why you hybrid the method classification and with clustering? Why?
Why use 2 method?
Two
Why use
method hybrid. You hybrid,
classification?
right? You hybrid, right?
Oh. SPM perform well and small dataset and provide stable classification while K-means help uncover patterns. Combining both allow use to gain predictive and structural insight from the same data.
Okay, Miss Alfi. Thank you, Miss Tania.
All right.
Thank
Thank
you.
you. Thank you, Miss Tania. Very good.
Yes.
The time is very good. You still have a few seconds. I think that's all from you. Thank you.
Thank you, Miss.
Okay. Now we'll move to our next presenter. The title is a digit recognition techniques in digital measuring instruments. Current trends and opportunities will be performed by Adindra Ega. Adindra Ega, Mr. Adindra,
Yes,
are you
Miss.
ready?
I'm ready.
Okay. Okay, your time is 10 now, please.
Yes. Is my voice clear and my slide display on the screen?
Very clear. Yes,
Thank
very
you.
clear. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Adindra Vikarega. I am doctoral student from Universitas Indonesia, and I also a researcher in BRIN. And I want to present my paper with entitled Digital Recognition Technique in Digital Measuring Instrument, Current Trends and Opportunities. So This is the outline of my presentation. Start from introduction, method, result of the discussion, conclusion, and then list of the reference used. Okay. Okay, in industrial application, digit measuring instrument are preferred over analog due to its high resolution, accurate measurement, custom settings like unit, changing unit, clear display, and data logging feature for several models. And also, digitization of analog instrument becomes a recent trend in many fields. For example, in medical devices. And manual reading in water meter, it is also labor cost to record in every visit. And that may also, if there are any false reading, it will make incorrect billing cost for the customer. And in calibration industry, manual calibration with manual reading and data entry, this is time consuming and it will prone to human error. And if there's any error, it will make incorrect calibration report. So it needs an automated reading of digital measuring instrument become necessary to improve accuracy, reliability, and efficiency. So we need to develop and implement digit recognition techniques or method for this kind of application. This paper study and conduct about the review, systematic literature review with Prisma framework to review current trends and digit recognition techniques for digital measuring instrument, covering the traditional and modern approach with the following research question. What are the types of digital measuring instrument that is often used for digital recognition application? And what are the techniques used for image processing and digital recognition? And what is the accuracy of the proposed method? The keyword used for the literature, there are 7-segment digital recognition, LCD digital recognition, UV digital recognition, and so on. The search was conducted on Google Scholar for English with a paper with the time frame from 2017 until 2025. Then the exclusion, like the document with the title of handwritten digit recognition and license plate recognition, were excluded because this is different application domain and cannot be categorized as application for digital measuring instrument. And this is the finding results. So after conducting the review, I get about 43 papers, and the proportions are 65% are article journals, and 35% papers are conference proceeding. And most of the article are from IEEE and MDBI with its 7 paper. And most of the conference proceeding papers are collected from IEEE with 13 papers. And the publication trends shows fluctuation with a significant increase between 2019 and 2021, and the peak in 2022 and 2023 with 8 publications. Despite the drop in 2024, the opportunities for the research in this field remain highly promising, driven by the vast, diverse measurement fields and its application. And this is the summary of my review result. So, based on the table 2, digit recognition mostly utilized for automated meter reading, such as water meter, gas meter, electricity meter. And it also applied to medical devices such as blood pressure monitor. And for industrial digital measuring instrument, most of digit recognition technique were used to digital multimeter or DMM. In terms of digit recognition technique, OCR, feature-based approach, machine learning classifier, were mostly used in the early 30s. Afterward, CNN began to replace handcraft feature method classifier. Then, a major shift occurred since 2021 with the widespread adoption of YOLO-based object detection. YOLO often used to crop the region of interest of the LCD, and then recognition was done with OCR or feature-based approach. However, the recent papers now shows the capability of YOLO to perform direct digit recognition of digital measuring instrument. Thus, it enables possibility for real-time data acquisition of digital measuring instrument. This is the example for the OCR base, and this is the example for recognition using feature base. This is the example using the traditional machine learning classifier. This is the example for deep learning approach with CNN, and this is the example for YOLO-based detection for digit recognition. From the comparison, it can show that the traditional machine learning approach shows strong performance, but limited to robustness due to lightning and angle variation, and it relies on manual feature engineering. Then CNN and CRNN, they has advantage of automatic feature extraction, but has slightly lower accuracy. And then OCR-based method reaches 93% accuracy. It shows well performance for printed text, but struggling with digit representation. And then YOLO record the highest accuracy. And for the types of the digit, according to the digit, the highest average accuracy is digital multimeter, and the lowest accuracy was achieved on flow meter. So that this is indicating room of improvement, room of research opportunity for this type of digital measuring instrument. Overall, the various digit recognition technique present in the study shows high digit recognition accuracy result with consistently report above 90%. But the reported accuracy is only valid for each study because they use a different dataset. Those benchmark dataset should be used for comparison, for fair comparisons, such like MNIST or like COCO dataset for object detection. Then I conclude my paper. The digit recognition will shift from OCR machine learning classifier towards deep learning based approach, and YOLO-based object detection emerged as the dominant trend with highest accuracy digit recognition. Yes, the challenge is lack of standardized benchmarking dataset. Thus, it will create a generalization issue across diverse digital measurement instrument types. Thus, for the research should prioritize development of benchmark dataset for digit recognition. And also research opportunities of digit recognition in industrial still very wide open, considering various digital instrument type and diverse of measurement fields itself. Okay. That's all my presentation. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay. Your time is up. Just right about you finish your presentations. Maybe if there are any questions, maybe just 1 minute. Mr. Hendra, do you have any question or the other participants?
No, Miss Afi.
No, all right. I think the presentation itself is so understanding. Even I myself, with absolutely zero about the digit measurements, can briefly understand what the presentation is about. Thank you, Mr. Adindra. Such a good presentation. Maybe we
Thank
will
you. Thank you, Miss.
move. Yes, thank you. Thank you. We will move to IT 14. The title is Click, Consult, and Buy. Exploring the influence of online doctor services on purchase decisions. Will be presented by Nashwadara Shakira. Are you ready, Nashwadara?
Yes, I'm ready.
All right. Okay, that's very good. Your time is 10 minutes, starting from now. So yes, please, time is yours.
Oops, sorry.
Okay, you ready? Yes, please.
Okay. Okay. Uh, can you hear me? Sorry.
Yes, of course, clearly.
Yes, I see.
Oh, okay. Good afternoons, everyone. My name is Nashwadara Farah Shakira. Today, I will present our paper entitled Click, Consult, and Buy, exploring the influence of online doctor services on drug purchase decision. This paper was authored by me, Mr. Erwin Halim, Balkis Zahira Felina, and Wan Ahmad Ilham Zaki from the Information System Department, School of Information System, Bina Nusantara University. This research examined how integrated online doctor services in e-marketplaces influence users' intention and actual behavior when purchasing medicines. Okay, so there is a problem statement. Digital transformation has significantly changed the healthcare sector in Indonesia. E-marketplaces are no longer limited to product transaction, but now provide integrated services such as online doctor consultation and online medicine purchases. The COVID-19 pandemic further accelerated the adoption of digital healthcare due to the need of easier access, time efficiency, and the security of remote medical. However, despite the increasing usage of these platforms, several issues still exist, including lower user trust, inconsistent service quality, and hesitation in making online medicine purchasing decision. Okay, so this is the introduction, research problem, and also the gap. So based on the previous studies, have mainly discussed factors such as trust, service quality, price perceptions, and user satisfaction separately. There is still limited research that combines these variables into a single integrated model, particularly in the context of Indonesian e-marketplaces that offer online doctor consultation services. Therefore, a comprehensive model is needed to be better understand how psychological factors and user experience influence purchase intention and actual drug purchase behavior. So there is a 7 literature review. There is a 7 variable that I have been used. So there is a price perception, service quality, trust, user satisfaction, willingness to conduct online doctor services, purchase intention, and also drug purchase behavior. So for the methodology, this study uses a quantitative research approach and applies a structural equation modeling using the SMART PLS method. So the data were collected through an online questionnaire using a 5-point Likert scale, a total of 471 471 valid responses were obtained from Indonesia users who had previously used online doctor consultation or purchased medicine online. Purposive sampling was applied to answer respondent met the research criteria. As I explained before, there are 7 variables. So the first one is price perception. So for the price perception, it refers to user evaluation of price fairness, value of money, and the affordability of medicines. In e-market platforms, price does not only represent cost, but also reflects service quality and platform credibility. Our finding confirmed that price perception has direct and significant effect on purchase intention. For the second one, there's service quality. Service quality represents users' perceived quality of services, including timeliness, system reliability, responsiveness, completeness of services, and the professionalism of online doctors. Therefore, service quality play a fundamental role in building trust within digital healthcare and services. For the third one, there's trust. Trust refers to user level of confidence in e-market platforms, online doctor consultation, and the online drug purchasing system. Higher trust levels significantly increase purchase intention, user satisfaction, and users' willingness to use online doctor service. For the fourth one, there's user satisfaction. User satisfaction reflects overall evaluation after conducting online doctor consultation and purchasing medicine through e-market platforms. Satisfied users tend to trust the platform more, demonstrate stronger loyalty, and show a higher likelihood of repeat purchases. Okay, for the fifth one, there's willingness to conduct online doctor services. Willingness to conduct online doctor services represent user readiness to engage in digital medical consultation. In this study, willingness acts as a mediating factor that bridges online consultation and actual purchasing behavior. So for the sixth one, there are purchase intention, and for the seventh one, there are drug purchase behavior. So purchase intention refers to user intention to purchase medicine after receiving information or consultation through online doctor services. Drug purchase behavior represents user actual behavior in purchasing medicines to e-marketplace platforms, which is influenced by purchase intention and also willingness to use online doctor services. So there is the model, and this is the questionnaire. So for the results show that all proposed hypotheses are statistically significant, like auto-loading majority more than 0.060 and composite reliability or CR all above it too, AV and discriminant validity. So service quality has strong positive effect on trust, and trust strongly influence user satisfaction and willingness to conduct online doctor services. Purchase intention is the strongest predictor of actual purchase behavior, while willingness also play a significant role. Overall, trust emerges as the most important mediating variable in the model. Okay, so here is the significant hypothesis. So for the conclusion, in conclusion, this study confirms that drug purchase behavior in e-marketplaces is jointly influenced by price perception, service quality, trust, user satisfaction, and willingness to conduct online doctor services. Service quality and trust are the most influential factor in shaping purchase intention and actual purchasing behavior. Therefore, in marketplaces, platforms should focus on improving service quality, price transparency, doctor credibility, and consultation convenience to enhance user engagement and transaction rates. Okay, thank you for your attention. The reference used in this study are listed on this slide. I am happy to answer any questions. Thank you.
All right. Thank you, Nashwadara. You still have 1 minute left. Is there any questions? Please. Maybe from me, just a brief questions, Nashwadara. What is the reasons behind your research? What is the most significant background? Why did you choose to analyze the behavior of users' willingness to purchase the drug on the online? Why?
Oh, I think because there's a lot of lack information that have been spread, that there's a lot of medicines that there's a lot of medicines that have the wrong informations.
Oh,
I mean,
I
like,
see.
yes.
Misinformations, you mean?
Yes, misinformation.
So you need to find out why.
Yes.
Is that right? You need to find out why the misinformation is spread. Why? So your finding is trust and service quality is the most influential variable in purchase decision, right?
Yes, that's right.
Yes. Service quality, maybe service quality in a marketplace or service quality in online consultation.
I think both.
Service quality in online consultations or both? Oh,
Yes, both.
both in e-marketplace and also online consultations.
Yes.
Oh, okay, okay. It's very good.
Okay, thank
Any
you.
other questions? The time is up. I think that's all. Nashwadara, thank you. Such a
Okay,
nice
thank you.
presentation. Thank you. Thank you. All right, we'll move to the next presenter with the code of IT 15. The title is Classifications of Adenocarcinoma in Body Fluid, Smear Imaging Using Deep Learning. Will be presented by Yesi Jusman. Are you with us, Yesi? Are you ready?
Yes, Miss.
Okay, right. So, again, your time is 10 minutes. I will be counting down. If you're
Is my screen clear enough?
Yes, it's clear.
Okay, thank you. Wait, Miss. Sorry.
You are still on mute. Please unmute first.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Thank you for the time. Today, I would like to present our research titled Deep Learning Classification of Benign and Malignant Cells in Pleural and Peritoneal Fluid Histology Smears. To begin with the background, adenocarcinoma is one of the most common types of cancer. This cancer originates from glandular epithelial tissue and can arise in several organs like lung, prostate, pancreas, colon, and breast. In clinical practice, body cavity fluid such as pleural and peritoneal fluid are often used to detect malignancies, particularly when identifying adenocarcinoma. The detection of adenocarcinoma usually involves a combination of clinical, medical, and several imaging techniques. The traditional techniques such as biopsy, histopathological examination, and various imaging techniques are very helpful for pathologists to detect the cancer, but these techniques are often require considerable time and may lack sufficient of sensitivity for early detection. So therefore, the study proposed a deep learning-based classification system to detect adenocarcinoma cells, which have the potential to overcome the limitation in current diagnostics, such as time-consuming procedures and limited sensitivity and specificity in early detection. The dataset used in this study consists of 1,273 histology images categorized into 4 classes: malignant peritoneal, malignant pleural, benign peritoneal, and benign pleural. The proposed classification system consists of 3 main stages. There are preprocessing, training, and testing. To prepare the dataset, the preprocessing stage was performed, including clustering to ensure that the dataset was clean and representative, and then followed by image normalization to 224 by 224 pixels. For the training stage, 2 deep learning models were used. They are AlexNet and ResNet-50. After training stage, the performance was evaluated using accuracy, precision, sensitivity, specificity, and F-score. From training results, the AlexNet shows strong performance. It achieved high accuracy. The accuracy values between 92.98% to 98.25%, with an average accuracy of 96.17%. This model executed efficiently, with the average time is 6 minutes and 50 seconds. For the ResNet-50, it achieved a higher performance. The average accuracy values is between 97.37% to 99.25%, with an average accuracy of 98.69%. However, achieving a better accuracy, it needs a slightly longer training time at around 9 minutes and 8 seconds. For the testing result, the AlexNet achieved an average accuracy of 88.97% with a high specificity of 92.36% and F-score 82.53%. On the other hand, ResNet-50 also achieved a high accuracy in testing. The average accuracy is 88.63% with high sensitivity of 85.58%, outperforming AlexNet sensitivity. Besides that, this model also achieved a high specificity and as well as the F-score. The confusion matrix highlight those results further. Both model performs very well, and AlexNet shows a perfect prediction in class 3, but it struggled in class 4 because there are 14 images that were misclassified to another class, and the ResNet-50 shows 0 misclassification in class 1 and class 3, but also face a challenge in class 4. In conclusion, both model AlexNet and ResNet-50 show strong performance. However, the ResNet 50 achieved the highest accuracy, reaching up to 99.25% in training, showing better sensitivity in testing and also maintain comparable precision and specificity. These findings indicate that deep learning has a strong potential to support histology diagnosis and improve the early cancer detection accuracy. I think that's all from me. Thank you for the time.
All right, you still have 3 minutes, maybe. Mr. Hendra, do you have any question? No?
No,
No, all right.
no.
For me, it's also no. Maybe that's all from Miss Yesi Jusman. Thank you for your outstanding presentation. Thank you very much. All right. So we will move to presentations with the code of IT 17. The title is Personalized Online Course Recommender System with Truncated Singular Value Decomposition and Clustering approaches. Will be presented by Haidar Prayudi, right? Are you
Yes.
ready? Okay.
Can you hear my
Haidar.
voice clearly?
Yes, very clear.
Okay. Can you see the screen I present?
Yes, clear, very clear.
Okay. Hold on. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. My name is Haidar Rizaldi Putra Prayudi, informatics major student from Telkom University. As the first author, I will present our work titled Personalized Online Course Recommender System using Truncated Singular Value Decomposition and Clustering Approaches. Okay, here I will start with the background and problem definition, followed by related works, objectives, dataset description, system design, results, and finally the conclusion. So this research proposes a recommendation system that combines term frequency inverse document frequency of TFI or TF-IDF, truncated singular value composition, clustering algorithms, and collaborative filtering. The idea is to improve prediction accuracy by grouping similar users and reducing data sparsity before applying matrix factorization. Online learning platforms generate massive amounts of user reviews. These reviews are high dimensional and sparse, which makes rating prediction challenging. Traditional collaborative filtering struggles to learn from such sparse data. So to address this issue, we incorporate dimensionality reduction and clustering before running SVD-based collaborative filtering. Our work addresses two main problems. First is how to improve collaborative filtering performance on sparse review data. And second is how different clustering algorithms affect prediction accuracy and runtime. We aim to find the best trade-off between accuracy and scalability. Previous studies show that matrix factorization performs well, but is sensitive to sparsity. TF-IDF combined with SVD is effective in reducing the dimensionality of text data. Clustering helps form homogeneous user groups, improving personalization. However, very few studies combine all three methods, SVD, clustering, and collaborative filtering, especially for course recommendation. The objectives of this research are to reduce feature dimensionality using truncated SVD, to group users into meaningful clusters, to integrate cluster labels into SVD-based collaborative filtering, and also to evaluate the accuracy and efficiency of each clustering method. Here are the dataset we used. We used a 5% sample of the Coursera review datasets provided from Kaggle. Each record contains a user ID, course ID, textual review, and rating. The text is processed into a sparse TF-IDF matrix, which is later reduced with SVD. There are three characteristics: sparse TF-IDF matrix, high-dimensional text data, and also noisy natural language input. The date reviews attribute was excluded as temporal information and not required for the recommendation process. System design. This figure shows the overall workflow. We start with text pre-processing, extract the FIDF features, and reduce the dimensionality using truncated SVD. Next, we perform parameter tuning and apply four clustering algorithms, which is k-means, dbScan, GMM, and AHC. Cluster labels are merged back into the user data and used to train cluster-specific SVD models for rating prediction. Finally, we produce evaluation metrics such as root mean squared error and mean absolute error, and we also generate top-end recommendations. Okay, so these are the 4 clustering methods which serve different purposes. So k-means is simple and scalable. Density-based spatial clustering of application with noise, or so-called dbScan, handles noise and nonlinear clusters. Gaussian mixture model, or GMM, provides soft clustering and fast performance. Okay, sorry for the lost connection there. Hold on. Okay. Agglomerative hierarchical clustering, or AHC, captures
I'm sorry, Mr.
multi-level
Haidar,
user similarities.
your presentation is not on the screen. Please share
okay.
your screen
Okay,
first. Your screen.
Okay, wait a minute. Yeah, I will share the screen. Oh, okay. Okay, can you see that? Yeah, I apologize for the inconvenience. Let's continue. So, AHC, agglomerative hierarchical clustering, or AHC, captures multi-level user similarities and tends to produce high accuracy grouping. So these are the results. First, accuracy. Here we present the root mean squared error and mean absolute error values for each clustering method. AHC achieved the best accuracy with an RMSE of 0.6535 and MAE of 0.4320 using truncated SVD. K-means perform consistently well. GMM and dbScan produce higher errors, but remain useful in other contexts. In terms of runtime, GMM was the fastest, followed by dbScan. AHC required more computation time, while k-means had the lowest runtime, the slowest runtime. A key observation is that the top-end scoring stage dominates total runtime, regardless of the clustering method. Okay, so this figure shows the trade-off between RMSE and runtime across 4 clustering methods. As you can see here, AHC achieved the highest accuracy at the cost of longer runtime, while GMM and DB-scan are faster but less accurate. K-means provides a balanced compromise between accuracy and efficiency. Here are the top 5 recommendation outputs for 2 user samples from each clustering method. From these findings, we see clear trade-offs. AHC provides the highest accuracy, K-bits offers balance and stable performance, GMM and DB-scan are more efficient but less accurate. The choice depends on whether the platform prioritizes accuracy, scalability, or responsiveness. To conclude, combining truncated SVD, clustering, and collaborative filtering improves recommendation quality for sparse datasets. AHC is best for accuracy, K-means is scalable, and GMM or DB-scan are suitable for time-critical applications. Future research could explore semantic embeddings, hybrid feature models, and online learning strategies. Okay, that concludes my presentation. Thank you for your kind attention. If there are any questions, I will do my best to answer them.
All right. Thank you, Mr. Haidar. Your time is up. Maybe just 1 more minute if there are any questions from the other participants. Is there any questions, ladies and gentlemen? No? All right. I think thank you very much for your sending performance.
Okay. Thank you very much.
Please close your next presentations with the code of IT 18. The title is A Comparison of Fixed and Adaptive Approach with Gaussians and B-square functions in geographically forests will be presented by Shaifuddin Zuhdi. Mr. Shaifuddin, are you with us right now, or anyone who will replace you, maybe?
Good
Mr.
afternoon.
Shaifuddin?
Yeah,
Oh,
the paper will present by me.
and you are Isla. Oh, okay,
Yes.
Isla. Okay. Yes, your time is 10 minutes. Starting from now, time is yours.
Okay, can you see my screen clearly?
Yes, of course. Yes, clear.
Okay. Okay, good afternoon, ladies and gentlemen. My name is Isla Nurfadila Ratbrasno, and today I will present our paper entitled A Comparison of Fixed and Adaptive Approach with Gaussian and B-square function in Geographically Weighted Random. And this research was conducted together with Mr. Saifuddin Zuhdi and Isna Nurul Fatati. This presentation will cover 4 main parts. The first is introduction, and then method, results, and so the first one is the background. So in specialized models such as GWRF, model quality is greatly influenced by 2 key components. The first one is kernel function type, and then the second is bandwidth CM. The kernel function determines how strong the influence between location is, while the bandwidth determines how many neighbors are considered. Therefore, the selection of the appropriate kernel and bandwidth is very crucial because it will greatly affect the accuracy and complexity of the model. And the research problem are, the first one is, the GWRF model combines the advantage of random forest and geographically weighted recursion, but its performance is highly dependent on the selection of kernel function and bandwidth. Secondly, the uneven spatial distribution in Indonesia poses challenges for the use of fixed and adaptive bandwidth. Additionally, spatial variation of the Human Development Index, or SDI, in Indonesia is very. So the objective of our research, the first one is to compare the performance of 4 kernel types, Gaussian versus p-square, with fixed and adaptive scheme in the geographically weighted random forest, or GWRF model. Is to evaluate how bandwidth selection and kernel functions influence prediction accuracy and model complexity using R-squared, AIC, and MSE. And finally, to identify the optimal kernel that provides the best balance between predictive accuracy and efficiency for SDI prediction across 514 districts or cities in Indonesia. So the dataset was obtained from Central Statistics Agency of Indonesia using 2024 dataset. And the dependent variable is Human Development Index. And the independent variables include life expectancy, expected years of schooling, average years of schooling, and adjusted data expenditure. Spatial coordinates, specifically latitude and longitude, were included to capture spatial effects in the GWRF model. So in total, the dataset consists of 514 districts and cities across Indonesia. So the research process began with exploratory data analysis and data preprocessing, including normalization. And next, we computed the distance metrics and constructed 4 GWRF models using different kernel types. The first one was fixed quotient, and then adaptive quotient, fixed b-square, and adaptive b-square. And then the model performance was evaluated using R-squared, and MSE. Now, let me start with the results, beginning with GWRF by fixed quotient kernel. The GWRF model using the fixed quotient kernel achieved the lowest AIC value of minus 1,602.14 with an R-square of 0.972 and MSE of 0.03. This indicates an excellent balance between high prediction accuracy and low model complexity. Therefore, this model was identified as the best performing model. The second result is the adaptive quotient kernel. The adaptive quotient kernel also achieved a high R-square value of 0.973. However, its AIC value is significantly higher, indicating increased model complexity without meaningful accuracy adjustment. Next, the adaptive b-square kernel. The adaptive b-square kernel produced the highest R-square value, but the improvement was marginal compared to the fixed quotient kernel. Its AIC value remains considerably higher, suggesting a trade-off between accuracy and efficiency. So we move to the key insights and discussion. So across all models, R-square and MSE value are almost identical, showing that all GWRF model or GWRF variant perform well during spatial heterogeneity. However, the AIC value differs substantially. The fixed quotient kernel consistently provides best AIC, meaning the best balance between accuracy and model complexity. Meanwhile, the fixed b-square due to very small bandwidth values, many weights equal to 0, resulting in singular matrix, so it's not suitable for this dataset. In conclusion, the fixed quotient kernel is the most suitable choice for GWRF in this study. It provides the optimal balance between prediction accuracy and model complexity, outperforming adaptive and B-square-based kernels. These findings highlights the importance of careful kernel and bandwidth selection in geographically weighted machine learning models. Although adaptive approaches offer slight accuracy gains, they introduce higher complexity. So overall, GWRF proved effective in modeling spatial heterogeneity in SEI data. And this study provides empirical guidance for kernel selection in GWRF, particularly for spatial socioeconomic data. So that's all. Thank you for your attention. We're open to questions or further discussion. Thank you.
All right, thank you, Ms. Isla, for your presentations. Is there any questions from the other participants? And no one? All right, maybe that will conclude your presentation. Ms. Isla, thank you very much for your time and
Thank you
for
very
your
much.
presentation. All right. And the next presentation will be presented by Mr. Fahru Rozi Lubis with the title of Smart Helmet Compliance AI-Driven Detection of Motorcycle Riders with ZFNet and MobileNet SSD. Mr. Fahru Rozi, are you with us already, or is there any replacement on your behalf?
Maybe I my replacement to Mr. Amin.
All right, your name is Muhammad. Can I call you?
Muhammad.
Can I call
Muhammad
you?
Amin.
Muhammad. All right, Muhammad.
Okay, but for me next
Amin.
next Amin, I'm present with my other papers.
Are you ready? All right, here. Please share your presentation first. Smart. Yes, of course, very clear. This your time starts now. All right, thank you, Mr. Muhammad Amin. Yes, right. Am I right? Yes, okay. You still have 2 more minutes. Maybe is there any question? Maybe from me. I just want to know in simple term, what is your main goal of your research? Why do you want to classify whether the motorcycle riders wear helmets or no? What is your main goal of your finding in this research, Mr. Muhammad Amin? Hmm. Hmm. Mm-hmm. Mm-hmm. Oh, okay. All right. So, uh, how do you implement your findings? Will be implemented in what? In the helmet itself or what? What kind of the system that you will use your finding? Mm-hmm. Mm-hmm. Oh, all right. That's okay. That's very good intention and very visionary. Maybe you can collaborate with the other researcher for your article to be implement. Okay. Thank you, Mr. Muhammad Amin, for your amazing presentation. We will move to our last presentation. The title is Multilingual Sentiment Analysis Model Based on Bidirectional LSTM on Bali Island Tourist Reviews will be presented by Sarah Purnamawati. Miss Sarah, are you with us?
For presenter is for me, not
All right.
Mrs. Sarah Canada.
All right. Can I know which one of you that will
Farurozi.
replace Miss Sarah? Fahru Rozi. All
Yeah,
right. Okay.
yeah, Farurozi.
Are you ready, Fahru Rozi? Please, Fahru Rozi. All right.
Oh yeah, yeah. Oh,
Please,
no, no, no. Okay, I have
on cam
on my
first.
video.
Yes.
Oh, yeah.
Yes,
Thank
yes.
you. Yes. All right. Yes. Mr.
Okay,
Fahru
all right.
Rozi. Yes, time is yours. You have 10 minutes.
Okay. Okay, thank you. Good afternoon. My name is Farurozi Lubis. We are from Universitas Sumatera Utara Medan. So, uh, I have a privilege to presenting our research on classifications of cybercrime case based on type of ITE law article using text convolutional neural network. So, wait, yeah.
I'm sorry, Mr. Fahrozi, your title is multilingual sentiment analysis, no? Because
No, classification of cybercrime.
all right, simplification. Mr. Hendra, can you help me, please? Because in my data, the title is multilingual sentiment analysis model based on bidirectional statement in Bali. Tourist reviews. The author is Sarah Purnamawati.
Yeah, the first author.
The first author.
Okay. My paper is IT20.
Yes, IT20. Yes, that's
Yeah.
correct.
IT20
But
with the title.
But the title
is
different.
No, in my email, classification of cybercrime case based on type of article IT using wait, using text CNN. Okay.
I think the title is correct.
Wait a minute.
Multilingual in room 3. Multilingual ring sentiment analysis in room 3, I think. In the spreadsheet parallel session.
Oh, all right. All right. Classifying text convolutional neural network. Is that right? Mr. Fahru Rozi, please.
Yeah.
Mention again your title.
My title is classification of a cybercrime case based on type of article undang-undang ITE
using text
using
convolutional neural network. Okay.
Yeah.
All right. The incorrect one is on me. Yes, please. You are good to go.
Okay. Okay, our title is classification of cybercrime text using text CNN based on ITE law article in Indonesia. With my friends, our team is Sarah Purnamawati, Faruroji is me, Jandrian Roham Simulun, Iqbal Fakriza, Trimurti Lubis, and the last is Romi Fadila Rahmat. So we are from Universitas Sumatera Utara, Medan. Okay. Let me begin by establishing the context and motivation our research. Cybercrime continues to scale daily in Indonesia, particularly in the form of illegal content violations, including defamation, extortion, fake news, and hate speech. The scale of this problem is alarming from January to September 2021 alone. We have 50,000 cybercrime complaints we reported through the Patroli Cyber portal. This represents a significant and growing threat to our digital society. However, despite legislation being in place, the remains article challenge limited public understanding of the ITE law in Indonesia. This knowledge gap system from two primary factors. The first one is insufficient explanatory information in news article about the crime case, and the second is limited accessibility to legal expert due to cost, time, and communications barriers. Disconnected between legislation and public understanding create an urgent need for innovative solutions. So this is the problem statement. The problem statements is the lack in information, like new articles don't fully explain violation type in cyber crime case. The second is the limited access for cost, time, and communication barriers prevent direct expert consultation. And the third for the problem statement is the public awareness. Public awareness is insufficient understanding of ITE law among in Indonesia citizen. And then the solution is automated classification system using AI to classify cybercrime case based on ITE law article. So this is Indonesian ITE law for overview. Before delving into our methodology, it's essential to understand the legal framework we are working with. Indonesian law number 11 of 28, commonly known as the IT law, regulates our action related to information and electronic transaction in cyberspace. Our research focus on 8 classification categories related to illegal content. That's like the first is Article 27, Paragraph 1, 27, Paragraph 2, 27, Paragraph 3, 4, and then the Article 28, Paragraph 1, Paragraph 2, and then the Article 29. For the methodology, the first now let me walk you through our research methodology. Our process consists of 4 main stages. The stage 1, data collections. We gather 660 cybercrime case chronologies from the Indonesian Supreme Court decision directory website, ensuring high quality and then the legally validated data. Stage 2, text preprocessing. This is the involves cleaning and then tokenization, stemming, and stop word removal to transform raw text data into structured format suitable for machine learning. And then the stage 3 is word-to-vec embedding. Word-to-vec embedding. Here, textual data is converted to dense vector representation that capture semantic relationship between words. And the last is the stage is the text CNN model training. The pre-processed vectorized data is used to train our text convolutional neural network to classify cases into our 8 predetermined categories. This pipeline ensures systematic process from raw legal document to accurate automated classification. Okay, next the datasets descriptions. Let me provide more detail about our datasets compositions. We are collecting a total of 660 cybercrime case, which we are divided into 525 training instance, representing 80% of our data and 135 testing instance or 20 persons. As you can see from the distribution chart on the right, the dataset exhibits some class imbalance, like Article 27 paragraph 1, Article 27 paragraph 3, and then Article 28 paragraph 1, paragraph 2, and then the not classified category is contain 100 case. Okay, Article 27 paragraph 2 has 70 cases. Article 27 paragraph 4 contains 50 cases, and the Article 27 has only 4 cases. The smallest representation in our dataset. This imbalance, particularly for Article 27, present interesting challenge that we will address when discussing our result. All cases were sourced from the official Supreme Court decision documents, ensuring data authenticity and legal validity, critical considerations for real-world applications. This is the text processing pipelining. Data processing is a critical stage that significantly impact model performance. Let me explain our 5 steps pipeline. The step 1 is cleaning. From the cleaning, you can removing URLs, symbols, functions, and numbers that don't contribute to semantics meaning. Step 2 is case folding. Case folding is converting all characters to lowercase to ensure uniform text representation and equal weighting. Step 3, stop word removal. This is the eliminating common word without semantic value, such as the preposition and conjunctions, which reduce the dimensionality without information loss. Step 4 is stemming. Stemming is the reducing inflected word to their root form for Indonesian text. This means converting words like menuduhkan to tuduh. So we can stemming this word. And the last, this step 5 is tokenization. Tokenization is segmenting text into word units and converting them to numericals indices for model input.
I'm sorry, Mr.
And
Farrozi,
then
your
the
time,
model,
2 minutes more. I'm sorry. 2
okay, for the
minutes more.
models,
Okay.
okay. Yeah, for the hypermeter, we use the batch size test 32, 84, and 128. Drop-off rates is 30%, 50%, and 70%. For optimal configurations, we use batch size 32. Dropout is 0.5. So the best result is 70%. Yeah, 70%. And then for the result, overall accuracy 70%. Classification report F1 score. F1 score is recall for 100% recall. Not, yeah, wait, yeah. So can I to explain the result? For the conclusions, first the component for what to add text profiling effective, achieving 70% accuracy for classifying Indonesian cybercrime case into 8 IT law categories. Second, our optimal configuration CBOW architecture with 300 dimensional vectors, batch size is 32, and 0.5 dropout, provides the best balance, accuracy, and efficiency. For our key findings reveal several important sites. The model, dimension, and batch size, dropout significantly impact to classification accuracy. Class imbalance explained by Article 29 limited for 40 cases directly result in lower F1 scores for minority class. And then for the slide feature work, okay, you can the feature words data enhancement collect more subprime case data, especially for underrepresented categories with the balanced data sets across all 8 categories. And then pre-processing improvement, better handling on non-standard word and typos, context-aware text cleaning, multi-label classifications, enable model to classify case that fall under multiple IT law article simultaneously. And then the last is expand data source, which include non-core data, improve model generalization beyond legal documentations. Okay, that's all. Any question?
All right. Thank you, Mr. Farrozi. I'm sorry for the limitation of the time. All right. Any questions maybe for the last presenters today from the other participants? Anyone, maybe? No one? All right. Maybe that's all for your presentation. Thank you, Mr. Farozi.
Thank
This
you.
parallel session. Thank you. Lastly, is there any question or discussion that you all will maybe wants to Mr. Hendra, do you have any close opening maybe? Close statement?
We have a photo session, Miss Alfie. Photo
All right.
session.
I almost forgot. Yes.
Yes.
Please, everyone who's still in the room, please turn on your camera. We will have
Yes.
a photo session, right?
Miss Tanya, you can. Yes, Miss Nasi Wadara.
All right. The first one, please. Anyone smile? For the second one. All right, smile. Yes, already captured. Thank you. Okay. All right, ladies and gentlemen, we have come to an end of these parallel sessions. On behalf of the organizing committee, I would like to express my sincere participation and active contribution. Thank you. We are sorry if there are any limitation in our parallel session. I wish you all a good day ahead and enjoyable conference. Thank you again. We will conclude. Thank you. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.
Yes. Thank you, everyone.
Salam.
Yes, we all can look. Yes, thank you.
Recording stopped.
Thank you.
Thank you.
Enjoy
For the
Ma'am.
recording, if
Yes.
anyone wants to, thank
Yeah.
you. We will send the recording if any one of you
Yes.
needs the recording of this
Yeah.
breakout room. Thank you.
Thank you.